Hello, this is Mr. Cole here. We're going to have a look now at some similarity and the effect that it has on the areas of the shapes. Okay, so first of all, we're going to look at the ratio of the sides. So shape A to shape B. So the area of shape A, sorry, the sides on shape A, let's just look at the ones we know. We've got 2 on the smaller shape and 8 on the bigger shape. So the ratio of the sides is 1 to 4. Okay. If we look at the areas, first of all, well, if area A is 2 times 1, which is 2. And area B, first of all, we can see that's been multiplied by 4. So that side there has to be 4 if these shapes are similar. And 4 times 8 is 32. Simplify that fraction, 1 over 16. Okay, so we're looking at the relationship between this and this. Let's try another one. Okay, so circles. First of all, just a length. So we could pick the radius or the diameter. We'll pick the radius here. So we're comparing 2 and 3. Sorry, 2 and 6. So they're in the ratio of 1 to 3. Okay, looking at the areas, let's just do the areas in terms of pi. So the area is pi times 2 squared for the small shape. And for the other shape, it's pi times 6 squared. I can simplify that. I can cancel out these pi's. Okay, so I get 4 over 36, which is the same as 1 over 9. Okay, so again, we are looking at this ratio and this ratio. Okay, let's carry on. Let's do another one. Okay, try and pause it and do the next two ahead if you like. I'm going to carry on now though. So this one, let's compare 3 and 6. So we've got a ratio of a half, just looking at the side lengths. I would still get that if I compared these two. It'd be 2 and 4. Yeah, that would be the same ratio. If I compare the areas, half times base times height. So half times base times height here gives me 3. Half times base times height here will give me 12. So that's a ratio of 1 over 4. Try it on the calculator if you need to do these. So just, need to quit that. Quit. Yeah, so look, 0.5 times 6 times 4 is 12. So you can check what I'm doing is right. Okay, these ones, semicircles. Let's try it. So we've got the lengths in the ratio 10 to 15, which is 2/3. Over here, what we basically need is pi times the radius squared divided by 2. Okay, or instead of divided by 2, let's do times a half. Okay, and then on the bottom, we've got pi times the radius squared times a half. Can do a little bit of cancelling. I can cancel the pi's, and actually I can cancel the halves. Get the same ratio. So I've got 5 squared, which is 25, over, let's go over here, 7.5 squared, which is 56, I missed it, 0.25. Let's get our calculator to simplify that one. So 25 divided by 56.25. And let's look at that as a fraction. It's 4/9. So, what I need you to compare is look at the ratio of the lengths compared to the ratio of the areas. And actually the clearest one to look at is this last one. Look at the ratio of the lengths. Look at the ratio of the areas. See if you can generalize this with this statement at the bottom. So the area ratio, if two similar figures have corresponding linear measures in the ratio A over B, then the areas have the ratio. I'll leave that to you to fill in.